Hello everyone, welcome back in another video. I am Vaibhav. In our today's video, we are going to see difference in between processes and threads. So today's date is 16th of August 2022 and we are going to see our today's video. So in our today's video, we are seeing difference in between processes and threads. So before going to the difference, let's see what is process and what is threads. So process is nothing but whenever we giving any command or we are have to do any process, we are giving some execution of code for the system or execution of any program. That time we are called as a process. Let's suppose I am whenever I am giving a command for execution in any code, that time that is my process. Or in our real time, we can see if I am opening an application of um, Gmail, that time that is one of my process. That is the process. There are multiple processes like opening an Gmail. Opening we are doing some multiple process like opening Gmail. At a time I am opening a music player. At a time I am opening a Paint. At a time I am opening a Word file. Like these are all comes under the processes. And thread means thread is a sub part of processes. That means whenever we executing any process, that time thread will be generated. That means I am opening giving a execution for the opening the Gmail. That time within Gmail I am doing some task like composing the mail, reading the mail, or deleting the mail. That time for each function there was creating and thread for the each. So that is the meaning of processes and threads. So as we seen, there are multiple taskings in our processes. That's why the process is a heavyweight. That means it has a load on the system. And in another case, there is a thread. Threads are light in weight because they are sub parts of the processes. This comes under the processes. After that, our next point, that is the context switching. Context switching means, let's suppose I am writing any code on Eclipse. That time I have to listen a song. That means I have to uh, I have to switch the one application to another application. That means whenever I am switching a contact, that time our processor can perform only one task at a time. That means I am opening a Eclipse for coding, and also again I am opening a VLC media player for listening the song. That time our processor can perform one by one operation. It can execute first the Eclipse and then VLC, like vice versa. It can work as per their requirement. So difference between that execution, the time required for that switching, that is within a fractions of seconds. So that's why we are not understanding that difference or that lag. That's why we can call as these processes are continuously, or we can think as all the processes are done at a time. That means multiple processes get done at a time, but that is not in really. There is a only one process can be done by the operating system. That is the our what context switching. That's why there is some lag of time or time required for that switching. That is more in case of processes, but in case of threads, that is time or lag is less as compared to processes, because threads are sub parts of processes that include within a one single manner. That means let's suppose I am opening a Gmail. That time that is one process, and within that process there is some threads like I am composing mail. That time I am clicking on compose tab. That time compose window will pop up window will be open. That time one thread is created. Again I have to check the inbox in my mail. That time I am clicking on inbox tab. That time inbox pop up menu will be open. That time the for opening the inbox, that is one more thread is generated. So that is the that is the threads which are generated within the processes. So that's why these are generated within the one process. That's why it require less time for switching, context switching. That means after one by one process done with the same. After that, one more point, that is the communications. So communications in between processes are require more time, because as we see there is some lack of time between, because our operating system can execute the process one by one. It's work on firstly, then another, then another, then another. That means sequentially it work on differently, but it's not able to perform work at a time on whole system. That's why our processes require more time for communication, and threads are require less time as compared to the processes. After that, the next more important point, that is address of spaces. Address of spaces means the memory allocation. In our processes, the memory allocation is a uh, is a widely used, because when we are doing performing any process, that time for each process there are separately allocation of memory. That means you can perform any process on our machine, that time that machine can allocate some space within our head memory for that specific process. And as per we are creating different or number of processes at a time, that time it creates or it allocate different spaces for the different processes. That's why it's take more space for the processes, sorry, in head memory. And in another scenario, in our threads, there is thread is not actually allocating separate memory for the thread. In our case, let's take an example of again of Gmail. When we are opening a mail, that time some memory is allocated. Let's suppose there is a memory allocation of 10 MB. That is not actually, we are only take an example for the understanding. So let's suppose for opening the mail, that time our heap memory can allocate the 10 MB memory for this case, and within that I am performing some operations like composing a mail. So that within that time the thread is generated for composing that mail, or thread can convey that message toward the JVM and get call back for the pop-up window of composition of the mail. So that time it takes some space. Suppose there it takes a 2 MB of space. That means our threads are acquiring the space or memory from the process memory. That means it take some little bit memory from their process memory. That's why they are not require more space as compared to the process. That is one more topic that is important. After that, let's see the dependency. So processes are totally independent. They are do not have any independency between them, because they are not having any relation in between them. Why? Because I am typing a program on Eclipse, and I am listening a song on YouTube. That means there is not any connection between them processes. That's why they are not require any processes, or there is not any relation between the processes. And in another scenario, there is a relation between the threads, because threads are a sub part of a processes. That means all those are comes and under one scenario. That means they are dependent on each other, because threads are generating. Let's suppose I am listening a song on a YouTube. That time the thread is generated for that opening that YouTube. Then I am searching some song on YouTube. That time one more thread is generated. After that I am playing one more song with on YouTube. That time another thread is generated. That's why all those threads are dependent on each another sometimes. At least up to 90% the threads are dependent on each other in this case, but our processes are not dependent on each other. They are free. So after that, next point is our next point is our requirement of their sorry. Next point is that consumption of memory. Consumption of uh, resources. That means the data required for the specific task is more, because in our processes we require more data or more raw data for performing operation on processes, but that require more data as compared to thread, because thread is a sub part of processes that require less data for execution or for performing the thread operation as compared to the process. After that, next point, that is the time of creation. Okay, so when we are executing any process, that time it take more time, because the size of that process or size of that code is more as compared to the thread. So when we are creating a thread, when we are when we are using some process or executing some processes, that time it takes more time for creation because its size or because of its space of or memory of allocation. And in another side, threads are require less time for creation because it is a subpart that have a minimum time that require minimum time for creation or generation of threads. When we are just single click on our command, that time just there is a creation of thread. That's why it required less time for creation. And another one more point is time of termination. Terminating means eliminating. Uh, they same as vice versa for creation. When we are have to when our performance or work of our process is done, that means we are having some perform. Let's suppose I am listening song on YouTube. I have to board, then I have to quit the YouTube. That time I am closing the YouTube. That time the time taking for terminating or I have to close that process. That time after my work is done, after I have to close that process, that time taking for the closing is more as compared to thread, because when we are done any task on process, that task will be convey or that task will be processed by the thread. That means thread will be eliminated firstly as compared to the process, because thread is a sub part of processes. Due to that, the thread will eliminate first and then the our closing the processes. That is overall scenario. And one more important topic is that synchronization. That is a very important topic. Our processes are not require synchronization, but our threads are required a synchronization. So what is synchronization? We are seen in our previously videos. You can check out. So that is the overall difference in between process and threads. Thank you.